Those who are online are able to hear me?
Yes, sir.
Okay. You're able to see the screen?
Yes, sir.
Is it big or small?
Small.
Is it big now?
Yes, sir.
Okay. Yeah. So what was the last topic we saw? We saw the concept of series and parallel, right? Did we solve a problem based on it? Yeah. Okay. So the next concept that we need to know is energy stored in a capacitor, right? So what is the value of energy stored in a capacitor? So check your notes. U is equal to half CV square. You would have made a note of the derivation, right? So how do we derive this? So basically, wherever you see energy, what is the idea used behind the derivation? So you would have calculated the work done, right? And that work then you would have written it in terms of Q into, check your notes. It would have written it in terms of Q into dV. And this Q would have been written as CV multiplied with dV. Sorry, this is dW, right? So if you want to calculate the total work, you will integrate it as CV dV. You will take C outside, and integral of V dV is going to give you V square by 2. So this is the derivation, right? I hope you would have made a note of this, right? This is how you would have derived it, right? Now, this is going to be the amount of energy that is stored in a capacitor. Similarly, if I take this U, this is equal to half into, how can I write C as? C is equal to Q divided by V into V square. So V and V will get cancelled. You will get Q into V divided by 2. Similarly, U is also equal to half into, instead of V, what can we write? Instead of V, you can write it as Q by C. So this will be the whole square. So this is also written as Q square divided by 2C. Basically, there are three formulae for the energy stored in a capacitor. What are they? Half CV square, QV by 2, or Q square divided by 2C. So these are the three expressions, out of which this is the most commonly used one. Okay. So this is done, no? Now, based on this, we also would have seen what is energy density, right? What is energy density? It is the amount of energy per unit volume. So what is the energy stored? It is half CV square divided by, what is the volume of the capacitor? It is the area of cross section multiplied with the distance of separation between, right? So this will be equal to half into, what is the value of C? It is epsilon naught A divided by D, and this is going to be V square, the whole divided by A into D. So what will be the answer? And again, V also will write it as E into D, right? So E is equal to V by D, and V you write it as ED, right? So it will be E squared D square. On solving this, what do you get? You get half epsilon naught E square, and this is the expression for what value? It is the value expression for energy density. Energy density is basically the amount of energy per unit volume, right? I hope these two expressions are registered in your mind. So we'll do some problem based on this concept. Go to the exercise part. I asked you to do some problems yesterday, right? What were they? 2.5, 6, 7, and 8. Okay. So just to recollect, what is the question 2.5? Okay. Okay. So what would be the new capacitance if the distance between the plates is made half of the initial value and the medium is having a dielectric constant of 6. So what will be the answer? So if you observe, C is equal to epsilon naught A divided by D. What is C dash? K into epsilon naught A divided by D dash, because the area of cross section is not changed. So divide this with this. So C dash divided by C is going to be equal to K times epsilon naught A divided by D dash is going to be D by 2. The whole divided by this is going to be epsilon naught A divided by D. So epsilon naught A and this will get cancelled. So what is the answer? K divided by 2 is 3. So C dash will be equal to 3 times C. So 3 into what is the initial value of C? It is 8. It will become 24 picofarad. So this will be the answer. I hope it is clear. Where? No, it is 6 by 2, no? K is 6, no? Oh, 2 is going up. Okay, okay. Then it should be 12, no? It should be 12 then. So 12 means 12 times this value. So 12 into 8 is going to be 96. So it is going to become 96 picofarad. Yeah. So I hope you got this answer. Okay. So what about the next one? Is there anyone who is having doubt in this? Clear? You're clear? Next. So all of them are 9, huh? Okay. So the equivalent capacitance in series is going to be 9 by 3, which is going to be 3 picofarad. How did I write 9 by 3? Because you'll write 1 by CS is equal to, see, going forward, I'll use S for series and P for parallel. So 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Everything is 9. So you will get the answer as 3 by 9, but you should not leave it like that. You should take the reciprocal. So that will be 3 picofarad. That's what I wrote it directly. Right. Next. Okay. So listen to this. So there are 3 capacitors of equal capacitance which are connected across a 120 volt supply. Right. This is 9, 9, and 9. Now, what is going to be the potential difference across 3? Answer is very simple. You can directly tell. So answer will be 40, 40, and 40. Right. Suppose I change this question in such a way that this is 3, 4, and 5. So 3 picofarad, 4 picofarad, and 5 picofarad. Then how are you going to calculate the potential across each? How will we be same for series? Charge will be same. So first, what should I do? How will I calculate the charge? You cannot do it as 120 by 3. First step is you need to find the equivalent capacitance. So what is going to be the equivalent capacitance? 1 by 3 plus 1 by 4 plus 1 by 5. See, I took some random numbers. You will get fractions. Okay. So 1 by 3, 1 by 4, and 1 by 5. What is going to be the LCM? 20, 60, So here it is going to be 20 plus 15 plus 12. How much is it? 32 plus 15. So it is going to be 47 divided by 60. Okay. So this is the value of 1 by CS. What is going to be the value of CS then? So 60 divided by 47. So this is the equivalent capacitance. Now, what is going to be the equivalent? What is going to be the charge distributed by the battery? So Q is equal to CS into V. So what is CS? 60 by 47 into 120. Okay, whatever the number is, I'll call it as Q. Okay, I'm not worried about the number. I'll call it as Q. Then what is going to be V1 in this case? V1 will be equal to Q divided by C. So what is the value of Q? 60 into 120 divided by 47. Yesterday I told you, remember, never break the charge into 3 equal parts. The charge supplied by the battery to the equivalent capacitance will be the charge supplied to each capacitor. So this is an important point. I told you, most common mistake they'll do is they'll divide this by 3. Don't do that. So how much is the charge? V1 will be equal to Q divided by what is the value of C? It is going to be 3. Similarly, what is the value of V2? Q divided by 4, and V3 will be Q by 5. This is how you find. Am I clear with this? So this is how we solve when the capacitors are of different value. You can make a note of this. So you can note down the steps. So what are the steps to be followed? First find the equivalent capacitance. Then find the charge supplied by the battery. 1 minute. I'll give you the steps. So what are you supposed to do? Find equivalent capacitance. Second, what are you supposed to do? Find the charge supplied by the battery. Then what are we supposed to do? Third step. What is the third step? So what is the third step? Charge found in step 2 will be what? Charge across each capacitor will be the charge across each capacitor. Then what is the fourth step? Apply V is equal to Q divided by C across each capacitor. So this will solve. So when will you follow these steps? When you're asked to find the potential difference across capacitors in series. Parallel is very simple. You will not have this much headache. You need not find any equivalent values. Okay. See, generally, they'll ask you to find the potential difference in the case of series. What will they ask in the case of parallel? How they'll ask the charge across each capacitor. It's very much similar to what happens in a resistor, right? So when you have resistors connected in series, they'll ask you what is the potential across each resistor. When you have the resistors in parallel, they'll ask you what is the current. If it is resistor, they'll ask you current. If it is capacitor, they'll ask you charge. I hope I'm clear, right? Shall I proceed? Those are online. Shall I proceed?
Yes, sir.
Okay. So we'll go for 2.6. So what is 2.6? Oh, 2.7. What is the question? So 2, 3, and 4 are 2, 3, and 4 are connected in parallel. Okay. What is the total capacitance of the combination? Okay. What is the answer? By the, you can say 9. So total CP is equal to 9 picofarad. Okay. So if the is connected to a 100-volt supply, we need to find the charge across each. So how much is it going to be? If I call this as 1, Q1, Q2, Q3, this is very simple. Unlike the previous case, you need not do any manipulations. Directly, you know the potential difference. What is the potential difference here? So what is Q1? 200 picocoulomb. Q2, 300 picocoulomb. And Q3, that's it. That's the answer. So just apply Q is equal to CV and you're done. Right? Parallel is very simple to handle. Right? Yes. What is the next one? So shall I proceed? .8. Yeah, tell me. One minute. So in between it is air, so epsilon naught. Space of 6. Area 6 into. Okay. Okay. It's very simple now again. So what is the formula? C is equal to, it's a parallel plate capacitor, epsilon naught A divided by D. Epsilon naught is 8.85 into 10 power minus 12 into what is the value of A? 6 into 10 power minus 3, the whole divided by 3 into 10 power minus 3. This and this will get cancelled. So what will the answer be? 17 point something? 17.7. So 17.7 into 10 power, this and this will get cancelled. 10 power minus 12 picofarad. Sorry, farad. So it is going to be 17.7 picofarad. Right? Yes. Next. Okay. So basically they're asking what is the charge? Q is equal to CV. So C is how much? 17.7 into 10 power minus 12. How much is the battery? 100 volt. So it is 10 power 2. So it is going to be 17.7 into 10 power minus 10 or 1.77 into 10 power minus 9 coulomb, which is 1.77 nanocoulomb. You can take it in this way. Clear? So this is how it works. What is the next question? No, what is the next? I'm asking what is the question? I read it, no? Okay. Okay, listen to this. See, I'm going to discuss a concept now which is not there in your textbook. So I want you all to be prepared this table. You take a fresh page. So, physical quantities related to capacitor with and without dielectric, comma, battery connected or disconnected. Okay. So here I'm preparing a table like this where we have physical quantity, right? Then here you have without dielectric. Then this is with dielectric. And you have the battery connected, and the other part you have the battery disconnected. So understand this. So first thing, if I talk about capacitance. So if you talk about the capacitance without dielectric, then what is it going to be? Let me call it as C naught, where it is going to be epsilon naught A divided by D. Am I right? Now, within this, if you insert a dielectric, when I say insert, you are inserting it completely. You insert a dielectric and you keep the battery connected, then the capacitance C dash will be equal to K times C naught, where K is the dielectric constant, right? So same is going to be the case even if the battery is disconnected, because capacitance does not depend on the connection of battery. It is just like a water bottle you buy from a shop. If it is a 1 liter bottle, it can hold only 1 liter bottle, irrespective of whether you are going to fill water or not, its capacity is fixed. Similar is the case with the capacitor. Okay. Next is the concept of potential difference. So this is where the changes will start. So if I call the potential difference across the capacitor is V naught without dielectric, okay, then when you insert the dielectric between the plates of the capacitor and you still keep the battery connected, then the potential will still be V naught. Whereas when you connect when you insert a dielectric and disconnect the battery, the potential will fall by a factor of K. So it will decrease by a factor of K because the electric field will decrease. Am I clear with this? So these are the 2 points you need to remember. All other parameters can be derived from it. For example, if I talk about charge, so if I say the initial charge is Q naught, then Q naught will be equal to C naught into V naught. Right? Then what will happen to the charge when the battery is connected? Remember, you have inserted the dielectric, right? And you have the battery connected. Then what will happen? Q dash will be in such a way, see V dash is this thing, here V dash is this thing. Q dash will be equal to C dash into V dash. So how much will you get? You will get K times C naught into V naught. So what is happening to the charge? Capacitance is increasing by factor of K. Charge is also increasing by factor of K, provided you keep the battery connected. Now, if you disconnect the battery, then what will happen? Q dash will be equal to K into C naught into V naught divided by K. So when you multiply both, what will happen? You will have C naught V naught, which is nothing but the initial charge without the dielectric. So if you want the capacitor to hold more amount of charge, you need to insert the dielectric and keep the battery connected. If you remove the battery, it will fall by a factor of K and it will come back to its original state. Am I clear with this? So next is electric field. So what about the electric field? If I call the initial electric field to be E naught, right? So what will be the electric field in this scenario? E dash will also be E naught only, because E is equal to V by D. Distance is not changed. When V is V naught, E will also be E naught. Whereas what will happen here? It will become E naught by K. So I'm taking the reference of both because E is equal to V divided by D. Electric field is potential. What is the name of it? Electric field is potential gradient. V by D, right? Next is energy, which I'll call it as U. So what is the value of U naught? Half C naught V naught square. So what will happen here? Half into, so instead of C naught, I'll write C dash, which is K times C naught into V naught square, into V dash square, which is V naught square only. So what is happening? Half into C naught V naught square is U naught itself. So energy is, what is happening to energy? It is becoming K times the initial energy. It is increasing by a factor of K. So it is K times U naught. Whereas if I do U dash here, so if I do U dash here, then what will I get? Half into K times C naught multiplied with V naught square by K square. So what will happen? 1K will get cancelled. Half C naught V naught square is U naught. So it will be U naught divided by K. So here it will decrease by a factor of K. Okay. So this is a very important table. Make a note of this.
Sir, you're not audible.
Sorry. Guys, am I audible? Those are online. Am I audible?
Yes, sir.
Okay. See, the new capacitance will become K times C naught, irrespective of whether the battery is connected or disconnected. Right? What will happen to the potential? Did they mention anything about the battery? So in the previous case, did they mention anything about the battery? 100-volt battery is connected, no? Now, when the battery is disconnected, what will be the new potential? It will be 100 by 6. Correct? What is 100 by 6? 16. Huh? How much are you getting? 16.7 volt. Correct only, no? Yeah, 16.7 volt. Now, what will be the charge present on this? What will be Q dash? So, when the battery is disconnected, what is happening to the charge? It is coming back to the original value. What is the value we calculated in the previous case? In the previous case, what was Q naught? So 1.77 nanocoulomb. This will be the answer. So these are the changes that will occur to the new system. Suppose they had given the reverse, battery is connected, then what would have happened? So I'll solve that part also. This is when the battery is disconnected. So if suppose they say in the same problem, battery is connected, then what will happen to C dash? It is still 108. Am I right? What will happen to V dash? It would have been 100 volt. What would have happened to Q dash? It would have become 6 times 1.77. How much is it? 8 point. 10.2. Sorry, 10 point something nanocoulomb. I am not concerned about answer, but you understood the concept. So 10 point something nanocoulomb. So this is what is the change that will occur. So you can expect these kind of questions. Okay. They have asked this, if the battery is connected also. Okay. They asked? Connected. Once check the answer, no? Once check what have they given. That is 10 power minus 8. So if you take it as 10 point something, it will become nanocoulomb. Okay. So this is the first part, no? Second part is this matching. When the battery is disconnected, all the three are matching. Right? Pranav, any doubt? You're clear, no? So, yes. Then, shall I proceed? Yes, Sundar, you can do it on your own. Correct? Sort of. Which one? Second one or the first one? So second one, if you go to the previous, like you wrote the table. So in that, when the battery is connected, what is the value of Q that is coming out? That is K times Q naught, Lada. See, K times C naught V naught is Q naught. So what is the initial charge you had? 1.77. That will get multiplied with 6. Shall I proceed? Okay. Look at the next one. That's 600 picofarad something, that question. Huh? Simple question. So what is the 10th one? Huh? So how much is the capacitance? C is equal to 12 into 10 power minus 2 farad. Then what about the potential difference? 50 volt. So what is going to be the energy? Half CV square. So half into C is pico, right? 12 into 10 power minus 12 into V square, which is going to be 2500. So it's going to be 6 times. So can I write it as 6 into 25 into 10 power minus 12 into 10 power 2? See, this one I wrote it as 10 power 2. 6 into 25 is 150. In 10 power minus 2. Or if I move on 0, I can also write it as 50 nanojoule. Right? Correct. Let's look at the 11th one. Yeah. So what is the 11th one? That 600 picofarad thing, right? Okay. See, listen, you go to a last example of this chapter. Last example problem. Page number 82, no? So in page number 82, what is the question number? 10, no? Okay, example 10. If you observe that, right, read that question completely. So there is a 900 p. Sorry, read it. Okay, so first part of the question is you have a 900 picofarad capacitor and it holds a charge. Sorry, it is connected across a. It's connected across a 100 volt. So you have a 900 picofarad capacitor which is connected across. Okay. Now, what is going to be the energy stored in it? So half into C is 900 into 10 power minus 12 into V square. 10 power 4. So how much will you get? So 1 to 10 power 4. So 10 power 2 into 10 power 4 is 10 power 6. So 10 power minus 12 into 10 power 6 is 10 power minus 6. So what are you left out with? You're left out with 9 by 2 into 10 power minus 6. So you will get 4.5. What? How do you write it? 10 power. You write it as microjoule. Right? So 4.5 microjoule. Okay. What is the next part of the question? Okay. Connected to another uncharged, right? Is connected to another. Okay. Okay. See, if you take this 100-volt battery, right, it is storing some charge on this material, on this capacitor. So this charged capacitor is connected across another uncharged capacitor. So how much is the value here? It is 900 picofarad. Here also it is 900 picofarad, right? So this is charged, this is uncharged. Now what will happen? So this will start acting as a battery. This will start getting discharged and this will start getting charged. Because you will have a positive charge here, negative charge here. The positive will flow from higher to lower. Now this will acquire positive and this will acquire negative, right? So like this, the process will continue till something is attained. What is it? When will this stop getting discharged and when will this stop getting charged? So when they have the same, right? But that is wrong. That's not when it is stopped. They both have same capacitance only, then do not go at all. See, if this object is there, I keep it like this, is this moving? If I make it like this, it's moving. Why? If I keep it flat, it's not moving. If I do it like this, it's moving. Why? Because there is a difference in potential. Similarly, when you touch a hotter object, the heat flows from the hotter object to the colder one, right? So in a similar way, charge will also flow from higher potential to lower potential. So when will it stop? When they both attain not the same charge, when they both attain the same potential, right? When they both attain the same potential, the process will stop, right? See, I'll teach you a concept now. In this case, it is simple. Initially, how much is the potential stored in it? It is going to be 100, right? So how much, when will the process stop? When it becomes 50 here and 50 here. Why is it so? How did I tell it directly? Because they both are of same capacitance. So you can have a question where the capacitance is not the same. At that time, when will the process stop is what we are going to see. See, initially, let's say I have a capacitor of capacitance C1 and another capacitor of capacitance C2. Let's say it is at potential V1 and this is at potential V2. Initially, they are isolated. They have no relation between them. So what is the charge on this C1, V1? What is the charge on this C2, V2? What is the total charge of the system? It is C1, V1 plus C2, V2. So this is something like this. Now, if I take the same capacitors and connect them using a wire, right? So there will be a redistribution of charge taking place till this attains a potential V and this also attains a potential V. When the potential of both is same, the transfer will stop. I don't know which one is at higher or which one is at lower, but I'm just concerned about when will the process stop. So what is the new charge here? It is C1V. What is the new charge here? It is C2V. So the total charge of the system is C1V plus C2V. Now the question is, this is the initial charge of the system, and this is going to be the final charge, not of individual capacitors, the final charge of the system. Right? Now, the process is in such a way that the initial charge is supposed to be equal to the final charge, meaning C1V1 plus C2V2 should be equal to C1 plus C2 into V. So what is going to be the value of V? It will be C1V1 plus C2V2, the whole divided by C1 plus C2, where this V is what is called as the common potential. So if at all you have two capacitors of different capacitances and different potential difference initially, then if you need to calculate the common potential, then you can use this mathematical expression to solve. For example, in our problem, what is the value of C1? What is the value of C1? 900. What is the value of C2? That is also 900. What is the initial value of V1? 100. What was the value of V2? It is 0 because it is not charged at all. Then how to calculate the value of V? V will be equal to C1 V1, that is 9 into 10 power 4, or else I'll write it like this only. 900 into 100 plus C2 into V2, which is a 0, the whole divided by C1 plus C2. So it is going to be 1800. So how much will the answer be? So it is 100 into 900 divided by 1800. It will get cancelled. Answer will be 50. That is why I directly told it is 50. But this is how you obtain it. Am I clear? So this is actually a concept. This is also not there in your textbook. So please make a note of it. So which is called as redistribution of charge. So this is the concept of redistribution of charge when the capacitors are connected with the help of a wire. Done. So using this concept, solve this problem. So what is going to be the potential here? It will be 50. What will be the potential here? It will be 50. So what is the new energy of the system? U1 is how much? Half CV square. So it is half into C is 900 into 10 power minus 12 into what is the value of V square? It is 2500. What is the value of U2? Half CV square. It will be the same value. Half into 900 into 10 power minus 12 into 2500. So when you add these two, what is going to be the total potential? Is it not going to be CV square? Right. So when it is going to be CV square, this half will go. So you'll be left out with 900 into 10 power minus 12 into 2500. So what will this answer be? 1, 2, 3, 4. So 9 into 25 is 225. So 225 into 10 power minus 8, or this will be 2.25 into 10 power minus 6 joule, which is basically 2.25 microjoule. Listen to this carefully. Initially, the energy was 4.5 joule with only one capacitor. After you took this capacitor and connected it to another capacitor, the total charge, sorry, the total energy of the system itself is becoming 2.25 microjoule. So it has exactly become half the initial value. Where did we lose that energy? Where did we lose that energy? Obviously, when the charge is getting transferred from one capacitor to another, there is charge flowing through the wire. So energy will get dissipated in the form of heat. So energy is lost in the form of heat. Are you able to understand? So there is an energy loss taking place here. And if they ask you, suppose they extend the question and ask you, what is the amount of energy loss that has taken place? So if suppose they ask you what is the change, you will say 2.25. There are three ways in which they can frame a question. If they ask you what is the change, it is 2.25 microjoule. There is a loss of 2.25 microjoule. Actually, you will get the answer as minus. Because whenever change is asked, you will do final minus initial. You will get negative value. Negative indicates loss. Or they can ask you, what is the fractional value? So what is the fractional value? Change divided by original. 2.25 divided by 4.5. How much is that? Half. So fractional value, fractional loss is half. If they ask you percentage loss, how much will it be? So half multiplied with 100, you will have 50%. So these are the ways in which they can frame questions. See, with this, we have covered all the combinations of problems that are possible. Okay. Only thing is, I need to give you more practice on the series and parallel combination. You ask, how to find. I'll just tell you the outline. Did you complete making note of this? Just take a quick note. You can save time. Anybody has phone? வீட்டில் இருந்தானே வரீங்க ஃபோனே இல்லை ஃபோன் இல்லையா அப்படி எதில் பார்க்குற வீடியோஸ் ஆமாம் Done. Okay. See, if at all you have a doubt of how to find whether something is in series or parallel, right? It's very simple. The logic, you can apply this to resistors also. You look at this is positive, this is negative, right? So assume, remember, current will always flow from all these things which I'm telling, do it with pencil till you get practiced. Okay. So current will flow from higher to lower, right? So if it is going at this junction, what will happen to the current? It will get split. Okay. Let me call that split as I1 and the remaining will be I minus I1. You learn about this law. This is called as Kirchhoff's junction rule. You will learn about this in the next chapter. So as of now, remember this. Okay. See, this is one way. Or when this is plus, here you will have the positive sign. Here you will have the negative sign. I told you one thing yesterday. When 2 points are connected with the help of a wire, they both are at same potential. So this will be positive. This will be negative. So this positive charge will go and sit on this plate. This positive charge will go and sit on this plate also because they are the ones which are facing the positive charge. So if one of the plates is positive, the other obviously has to be negative. So here you have negative, this will be negative. I hope I'm clear till this step. So if this is positive, this will be negative. Okay, then what will happen to this? Why negative? This current is there, no, it is flowing like this. So then this has to be positive, this has to be negative. Because look at the direction of current. Current flows from higher to lower. Okay. So if you look at these three, negative is connected to positive, negative is connected to positive. So this will be series. Okay. After you solve this, how will the new circuit look like? CS. Okay. Now you have the battery here. How much? Okay, whatever is the value. This positive, this is negative. So this will be plus, this will be minus. This will be plus, this will be minus. Now positive and positive are connected, negative and negative are connected. They both will be in parallel. That's it. That's the logic. But there's a very, very, very complicated way of understanding. With practice, you will understand when it will come. But until you get practice, no, use a pencil and make a note of this kind of point. So what is happening when negative is connected to positive and negative is connected to positive, it will be series. When positive and positive are connected, it will be parallel. But when I say positive and positive are connected, there should only be one resistor across each. Sorry, one capacitor across each. See, for example, listen. Here, this positive and this positive are connected. You should not say that this and this are in parallel. No. You need to find the equivalent value. Then you need to check only across two capacitors. Okay. There was an additional problem, right? Additional exercise problem that actually you have to rearrange and do it. I thought of solving it, but yeah, time is not there. Could you understand this concept? See, the material which anybody has the material that is provided, the study material which we gave. You have it now? in those numerical questions, right? 3 or 5 marks, you'll have problems based on it. You can have a look at it and solutions will be available. Okay. So try them out. Yeah. Okay. So we'll wind up with this. Those who are online, any doubt? Those who are online, any doubt?
No, sir.